We had a couple of stories this week that had to do with research. And that's important because there are people out there that are doing this sort of research quietly for other purposes, crime, espionage. So I think that research is a great way to push things forward.
Hey, Matt, I heard you wanted to tell us about AVGater.
Yeah, it's a pretty interesting attack sequence. And it really is a chain of different little bits of attacks that when you put them together, you get something pretty cool out of it. So an independent researcher came up with this technique, calling it AVGater, because of course you have to name bugs these days, although his logo for it is a childishly colored in cartoon alligator, which I like that. It's basically a way of getting your malware running with elevated privileges on a host where AV is present, using some interesting tricks and properties of how AV handles quarantine files, on how Windows handles DLL files, and how NTFS allows you to sort of map or link one folder to another one. You have your malicious DLL, you name it like the DLL that some other privileged program is going to use. And then you make sure it gets detected by antivirus. Antivirus quarantines it, puts it in quarantine folder. While it's there, you create an NTFS junction that says that folder it just came from is actually somewhere in the DLL search order. You restore it. It says, okay, one, antivirus can do whatever it wants, basically, because it runs as system. So it restores it. It sees that you've pointed that junction to this other folder, and it says, well, I mean, antivirus can do that. So it writes it to that restricted folder in the DLL search order. And then you run that other program, and your malware runs as that, written to a folder that a normal user should not be able to put DLLs into. So that's the whole thing.
That sounds pretty fancy. Something like most of us would probably think, hey, I'd like to try that out one time. And I don't know if it'll work. I don't know if I have enough time to look at that right now. And then you're like, oh, you know what? It actually works.
And it works in more than one antivirus system. It's because that assumption was made that when you quarantine something, the folder you're going to put it back in is the folder you were supposed to put it back in the first place, without that NTFS junction problem that's been introduced. So at least 6 different antivirus companies have patched this already. And I think Microsoft says they're not vulnerable to it. It's interesting in that it's a bug that applies to a large number of different implementations of the same kind of functionality across vendors. And that's a powerful bug. If it was just in say, Microsoft's antivirus, and it's not, but if it was just in the one antivirus, it would be a limited use bug. You could attack people who have that, but everybody else would be fine. And it's interesting because usually when you see a bug like this that applies to a wide range of software, it's because it's in some sort of established protocol, like the TCP stack on an operating system. But this is like everybody decided to build their antivirus this way, and it just seems to work on a significant number of them. So the authors, quietly talked to the AV companies, and the ones that have fixed it have said, yeah, we're good. And I don't know how many others are still affected by it.
To me, it sounds like this is an interesting theoretical approach of something that you could do to trick AV systems. In my opinion, this was probably an effort to help AV companies to kind of see if they have this as an issue and help them resolve it. It does seem, though, that you have to have access to quite a bit to get this to work. Like you have to manually, I guess, restore or unquarantine something. Mm-hmm. Seems like you have to have access to the system already to take advantage of this sequence of events.
So I think it's probably easiest to do this if you're sitting at the machine and you've got a tool that you can click and you're in control of when AV quarantines things and you can manually unquarantine things. There's probably a way to do it all in code. So Jim, it sounds like there was an interesting write-up on the SANS handler diaries recently about inspecting the root certificates installed on a Windows machine using PowerShell.
Yeah, this was an interesting post that my friend Xavier Mertens did on the Internet Storm Center Handlers Diary, and a little background on why it's interesting. We've seen malware over the years that attempted to install its own root certificate in the Windows certificate store so they can then behave as a trusted certificate authority, and it doesn't pop up warnings when you try to browse to sites or whatever. But what Xavier discovered is that PowerShell treats the certificate store similar to a file system. From PowerShell, do an ls cert : and you can see the root of the of the certificate store. He did some playing around, and he wrote some scripts that looks at the certificate store. It runs out of Task Manager every 24 hours as a scheduled task. And if a new certificate has been installed or if one has been removed, it generates an event log. It's really simple to script this, and then you can push it out to all of the systems that you're managing. You can push it out to all of the servers in your domain, for example, or all the workstations in your domain for that matter. And just have a way of programmatically scripting, looking at the certificate store and seeing if anything's been changed.
Root certificates are often used for things like crypto and signing, and they have multiple functions, but there should be only so many of them on your machines. Either they came shipped with the machine or through an update or software that you installed, put them there. And if you find anything out of the ordinary, that can suggest that some malware has placed it there. Or if there's some that are missing, that may suggest some sort of tampering.
As system administrators, as security professionals, the certificate store is one area of the system that we really should be paying attention to. If bad guys can slip new root certificates in there, we can bypass some of our security. They can build new encrypted tunnels that we don't know anything about, that we can't necessarily see inside, to detect exfiltration of proprietary data or whatever.
I feel like that would be pretty useful from a hunting perspective, definitely. This is sort of digging through all the different boxes, the giant junk drawer of certificates you've got across your network and seeing what comes up.
Yeah, see what the differences are between the different devices in your enterprise. Why are they different, if there are any differences?
Why does this one server have 5 more root certificates than any of the other servers in my enterprise? Why does this domain controller have more root certificates in there than the workstations? Absolutely.
Jim's story was very interesting to me because it kind of represented an analysis technique people could take, especially if they manage a large network of machines. Why are these certificates installed on one machine and not another? And if you have a large enterprise, I think you would have a lot of findings. It'll take, of course, some time to run each of those down. I have a feeling I know what Matt will be doing after this.
Well, first I got to learn PowerShell, and then second, I'm going to go digging around, and yeah, that sounds good though.
Well, thankfully with this tool, if it was released, maybe other people
maybe I
can
don't have to learn as much PowerShell as I think. Yeah,
exactly.
Right. Xavier included the code for his PowerShell script right in his handler's diary, and so you can take that and if you are comfortable in PowerShell, you can tweak it however you want.
Well, thanks a lot, Jim. This has been interesting. I know what I'm going to do after the show.
So, Stan, I hear you've been looking at a new family of ransomware that you wanted to talk about?
Yes, the Magniber ransomware family. Now, this one was covered by FireEye and Trend Micro in blog posts, and I thought it was interesting because the tagline for this one is Magniber ransomware infects only the right people. And I wanted to make sure I was the wrong person. This is where we get into the meat of the problem. Who are the right people? So according to FireEye, a lot of the customers that were impacted with this seem to be in the Asian region. They're checking before running the malware if the language is set to Korean or not. If it is Korean, it's going to keep going. And if it's not Korean, it's going to stop. Why would you do that for ransomware? Unless maybe you were thinking of it more like as wiper malware.
The other interesting thing is that this malware had several mechanisms for determining whether or not it was running in a virtual machine, and even when it ran the virtual machine, it wouldn't automatically exit. In most cases, if you're targeting home users and all of a sudden your malware finds itself in a virtual machine, chances are it's under analysis. So at that point, most malware would quit. This malware does not. This malware starts collecting information.
It made me remember a piece of malware I was reverse engineering just last week, which is from a very famous and well-studied APT group that targets a very specific region. And in that malware, they also have VM detection mechanisms that also don't quit it sends this information to the adversary. Now, there's many ways to do VM detection, and this is one of them. So apparently, VMware, it has VMware tools. You guys are probably familiar with.
Sure.
How does that work? Well, there's a backdoor. This is a good kind of backdoor. There's a backdoor in the virtual machine that lets the VM and the VM tools like communicate between the host operating system and the guest operating system. So they use like an IO port call with specific variables to see what that returns. If you have VMware or VMware tools installed, you'll get one result. And if you're not in the matrix, so to speak, you get a different result. So that's how they know that they have VMware. Another thing that they could detect is if you're inside VirtualBox. The way they do that is also another unique way. They look to see if you have a very specific driver that they try to load or a specific file. So this is two ways. They look for a specific file or they try to load a specific DLL. If you're able to do either of those things, then potentially you're inside VirtualBox or you're outside. And here's the final one that this specific malware from this specific APT group was using. The visual property container extender instruction. So again, it's another one of those instructions in the language. If you run it inside a VM, one thing happens. If you run it outside of the VM, another thing happens. So for each of these three techniques, I actually went and I researched them on Google, and I saw that a lot of these techniques are already well known. But to me, the presence of one adversary using just these three techniques, because there's a lot more, actually is what we call a TTP, a tool, technique, or procedure that's specific to that adversary. And then, of course, all of this was very interesting once I read about Magniber, because it impacts a similar region of the world, and it does a similar type of thing. Now, the technique used by Magniber and these three techniques are actually different. But there's enough similarity in concept that I thought it was interesting to share with our viewers.
That is interesting.
There are probably 100 different ways of detecting that you're running in a virtual machine. The ones you've mentioned, you can look for particular device drivers, process names that are running. I've seen, dozens of these in various malware samples over the years.
They're just looking for, is it in a VM or is it not? And then what do they send home? Just that flag, or they send home some sort of other intel they've gathered?
In this particular malware sample, what was happening is, yes, they check for each of these flags, but they actually do more. They check for what kind of AV is present, what kind of security tools are present. What was interesting to me is they check for security tools that most people usually have in their sandbox. The presence of each tool is one bit in this flag. So they create these 3 or 4 different types of flags and send that on to the adversary. And then now the adversary has a very good profile of the type of security system. And I'm sure they use a machine learning algorithm.
I like your quotes around that.
To detect if maybe this is like a VM that's used for something just because that's the way the system is set up, or maybe it's a VM that's used for a security purpose. Because the types of tools that they were checking for, because you might have a virtual machine with antivirus, but it might be unlikely for you to have a virtual machine with a bunch of instrumentation tools and antivirus, perhaps. So maybe this is a technique the adversary uses to gauge, hey, where's my malware running? Because we know there's a lot of sandboxes out there that people kind of explode the malware, even let it connect out to the adversary. The adversaries are learning. This shows to me that certain of the adversaries, they know what's going on, and they're sending this type of information back to themselves so they can profile maybe if their attacks are successful or if they're getting detected by the sandboxes and things like that.
If I were someone writing malware and trying to capture information from when it gets run in a VM, I'd be collecting as much as I possibly could. Try and fingerprint the VM and not just say, am I in it? But, what's being done in here? What kind of analysis is this? Can I tell whose this is? Did they leave any of their tools around or make any mistakes in configuring it? And then ship that whole thing home, instead of just doing an OR on, is this VM detection true? Is this VM detection true? But
it was just an interesting set of techniques that this adversary chose to employ. And usually when we do our analysis, we kind of look for those kinds of things. And that gives us a little bit more insight into what maybe a specific adversary is thinking. I can use that information, or other analysts can use that information to kind of paint a bigger, better picture of the threat landscape out there today.
Internet weather was mostly the same this week. The top 4 on the most sources probing and most probe ports were the same. And that's been pretty steady for a while. So port 23 TCP is Telnet. Port 22 TCP is SSH. 1433 is MS SQL Server. 445 is SMB. And those have been at the top for, well, quite a while now. Going over to the most sources probing, 23 TCP is the top, 445 and 22, not much of a surprise there. 389 is LDAP, and that's up 14 spots. And that was pretty interesting to see. Last week it was down in 21st place, so it was just off of the top 20. Typically you wouldn't point this out to the internet. It's not impossible, but it's probably a bad idea because this is a server that contains a lot of your authentication information. And if someone can break into it through some other service, then they can mess around with your authentication. They can get the credentials off the box. They can add their own users. So it's a terrible thing to expose directly to the internet. And I can see why someone would be interested in scanning for it. So as we always do, we'll cover port 23 TCP. Remained pretty high in the last 30 days. There was a peak a couple weeks back, but it seems to have sort of leveled out here. Maybe a very, very slight downward trend and somewhere in the 130,000 scan sources per hour range with maybe a daily cycle there. Port 8545, Ethereum. There's only about 10 sources that are actually doing this heavy scanning of 8545, but they are determined. And I guess they're motivated by profit, potentially. But yeah, that one's the new star of our show, I think. It's not quite as big, but it's definitely the new one on the scene.
There were a couple of stories that we didn't cover in the show about a vulnerability in the Ethereum parity wallet that had caused some folks to get locked out and essentially made like $300 million worth of Ethereum vanish.
There was also another internet storm-centered handler diary, I think, about scanning port 8080, some sort of JSON RPC calls that are related to Ethereum as well. I don't know if that one's really been solved as to what the person who scanned is trying to do. It did not make it into our top 10, so I didn't include it here. So moving along, port 445 TCP is SMB, and we've seen a steady but slow increase in that ever since the WannaCry breakout. And this graph looks a lot like it did last week and the week before and the week before that. Those same sort of periodic peaks that you see in the number of scan sources. Although we're peaking out around 60,000, maybe 58,000 scan sources per hour, when about 60 days ago we were peaking around 40,000. So it's still growing. So there are still boxes being attached to the internet that aren't patched against these the Eternal Blue exploit and the related ones on port 445, and they just keep getting compromised. Yes. So I don't see any real end to this one. This one was an interesting one. Port 3076 UDP was not in the top 10 of scan sources. It was in the top 20. And it was rather unique, and I figured I'd mention it. The registered use for this port is this Orbix, which is apparently for distributed applications. It's some sort of protocol used for that. The main source of this scanning overwhelmingly is a host in Ireland, but I'm not aware of any vulnerabilities for this service. And there's other possibilities for this port as well, but it sort of came out of nowhere. And you can see like a daily cycle of these scans. It looks like maybe there's really one, like I said, you can see one source overall. There's always been a baseline. You can maybe see that blue line at the bottom there, but the number of scan sources has been going up. So it's interesting.
Usually when we see that, it's an indication of something happening that's new or interesting on the internet. So in this situation, it could be like a new protocol or something that's gaining popularity, maybe a new P2P protocol, maybe a new gaming software, or there could be a vulnerability. It's interesting that it goes up, but then goes down near zero there, which is interesting. I don't know what else to say about it. Whereas, when we looked at the WannaCry just before, it never really goes to zero. There's some sort of like a lower bound. So all of this scanning is somehow very, I think, tightly coupled together.
I think there's two things going on here. I think maybe that baseline there you've got there, that might be that one scan source in Ireland that makes up the bulk of the the number of flows, but we're looking at a list of scanned sources. And there's somebody else out there who's got a botnet and is able to come up with this many, although this is UDP. So we could be being fooled here. Someone could be sending out this traffic with spoofed source addresses. And I mean, someone may be trying to DDoS somebody's Orbix application with a number of fake scan sources, if you know what I mean.
Right.
So who knows?
This would be a good one to see if we can capture, get some packets and see exactly what's going on. Since it's UDP, the entire exploit could be in, one packet or a couple of packets or whatever. So this would be a good one to get our honeypots and see what we can find.
I agree.
I know what I'm going to be doing.
Yep, I'm setting up a listener, so.
Cool. That's quick. That's analysis in real time, folks.
Yes. Thanksgiving is coming up, and as a security professional, I'm definitely thankful to the community of other security professionals that is out there who are doing interesting research. They're making it available for others to learn from, because in order to defeat some of the more advanced threats and even the regular threats, it's all about this kind of collaboration.
I'm most thankful for the sharing among the professionals in the community. I learn a lot from what other people have to go through.
I'm thankful for working in a space that keeps me fascinated as opposed to bored. There's always something new happening, and I'd rather be, constantly busy than constantly bored. I feel that keeping engaged is really important for keeping me happy.